All right, we are now in chapter 7, and we're going to be looking at non-homogeneous linear differential equations with variable coefficients. So last time what we had was a linear differential equation, L of t, applied to the y equal f of t. So this is non-homogeneous, right? The non-homogeneous is this portion right here. And this is, of course, your linear operator. We're going to assume the coefficient of forcing are continuous over an interval. Okay, so last time what we did was we did Ly equal f of t. And in the last section, the two important things were key identity evaluations. That's one method. And anytime you use this, you can also use method of undetermined coefficients. And this is actually up on, as video, and you need to finish filling out the form, the worksheet. Okay. Now the key here is this has to be constant coefficient. And that the L is a P of D, where the P of Z is your characteristic polynomial. Okay. But the F of T needs to be in characteristic form. And what that means is it needs to be polynomial times exponential times sine or cosine. Or cosine. Okay, so then that's when you can use this. Okay, now what if we have variable coefficients? So then instead of L, right, you can't use this. You have to use, if it's L of t, then you can't use these two over here. Okay, so we're going to look at variation of parameters. Okay, so we know how to do it when the solutions of the associated homogeneous equations have constant coefficients. In other words, you know how to do Ly equal f of t because the associated is Ly equals 0, and you know how to find this. Okay, so you know how to find the YH from this. Now, what if there are variable coefficients? Okay, so if there are variable coefficients, then you're going to be given a fundamental set. Okay, so if there are if there are variable coefficients, we will give that to you. Okay, now suppose we're going to keep it real simple. We're going to do second order. Okay, so say you have a second order linear differential equation. Not necessarily with constant coefficients. You might, but you might not. If you don't, you will be given a fundamental set of solutions to, what are you going to be given it to? L of ty equals 0, right? You'll be given it this way. But you still have to find a particular, all right? So you're going to put, now remember when it's linear, you always put into normal form, meaning leading coefficient is a 1, okay? We're going to assume that the coefficients of the forcing are continuous, right, over some common interval. Okay. So let me go ahead. Now make sure it's a 1, all right? Because if it's not a 1, when you divide through, this will be different. So make sure that you have the leading coefficient being a 1 so that you have the correct forcing. Now, suppose you have a general solution to the associated homogeneous equation. If it's this form, you can find it on your own. If it's this form, we're going to give it to you, but you have to, you have the general solution. Okay, so here's the general solution. YH equals C1, Y1, C2, Y2, where the Y1, Y2 are linearly independent solutions or form a fundamental set of solutions of Ly equals 0. And it might be, non-constant coefficients. Okay, the main idea, we're going to have the constants here and here be replaced by variable parameters so that instead of the C1, you would have Y1. Instead of the C2, you would have Y2. Okay. You differentiate twice and you sub into the equation to find the conditions on the U1 and U2. So let's just go ahead and do that. Okay. So what we're going to say is if this is your homogeneous, all right, solution, whether we give it to you or whether you find it out yourself, now your particular solution will be very similar, except that for the C1, you have a U2, C1, you have U1, and C2, you have a U2, okay? So now what we're going to do is we're going to plug it in here and say left-hand side equal right-hand side and figure out what are the U1 and the U2. So before we do it, we know we need two derivatives. So let's take the first derivative, okay? So we have this. We're going to say first guy times the derivative of the second guy plus the second guy times the derivative of the first guy. So we just did this a moment ago, okay? So first times derivative of the second plus the second times derivative of the first. Okay, so we just finished that. Okay, so now let's go ahead and do the next one. So we're going to do first guy times the derivative of the second plus the second times the derivative of the first. So here we have this. So first guy times the derivative of the second plus the second times the derivative of the first. Okay, so we have this. Okay, now let's go ahead and take the second derivative. And we're going to do this one first, right? And this is first and second. So focusing your eyes on this, right? So you're going to have first guy times the derivative of the second guy plus the second guy times the derivative of the first guy. So that was the derivative of him. Now what we're going to do is take the derivative of this one. Okay, so we'll also, let me just clean that up. This is the first, this is the second. So we use product rule. So we're going to take the derivative of the pink and it's going to be right here. So we're going to say first guy times the derivative of the second one plus the second guy times the derivative of the first. So you can see this is the first guy times the derivative of the second plus the second right here times derivative of the first. Okay. All right, we finished him. Let's go and do the next one. Let's look at this. Okay, so let's go ahead and break this up. We're going to say plus first guy times the derivative of the second guy plus the second guy times the derivative of the first, derivative of the first guy. First derivative. There we go. So it was like this guy times the derivative of the second plus the second one times the derivative of the first. Okay. And so we've taken care of that. And now we go to the very last one. So here we go. This one right here. Let's just go ahead and fill that in. So we'll say first guy times the derivative of the second guy plus the second guy times the derivative of the first guy. Okay. So I've done all of that. And now what I'm going to do is just take out all that extra color because there's a lot of color going on. So I was just making sure that you could follow each step. Okay. And what we're going to do is remember, this is a particular solution. Remember, this is normal form. All right. And now what we're going to do is we're going to plug it in to this. Okay. So we're going to do left-hand side. And that's going to be y double prime p of t y prime plus q of t y prime. Okay, so everybody can see that this right here, y prime, is this right here, right? Everybody can see that's the y prime. So I'll go ahead, I'll grab all of him.
Is there a mistake in the second product ruler, the second term in y sub t double prime?
Let's take a look. First guy. Oh, yeah, there is. You're absolutely right. Thank you for that. because when we're looking at that, so he's saying, is there an issue right here, right? So it should be, let's see. So we should have first guy times, oh, wait. First guy times the derivative of this, so that's him, plus the second guy. So this one should be y prime times the derivative first. There we go. Thank you. That would have been really, when you make a mistake, it's just really bad, right? You'd be so careful with your bookkeeping. So thank you for that. Okay, so that is this. So I'm going to just grab him, or you can rewrite him right here. Okay, and then I'm going to copy the P of t. And that's this. And then we're going to grab this. And so you can see that that's this right here, right? So grab that, or just recopy. Now, but remember, of course, the whole thing, so you have to put into parentheses. Plus, I'm going to copy down the Q of t. Everybody can see? The Q of t is right here. So just copying him. Now I'm going to copy that. So this, I have to write it out. So, because that was not handwritten. So we're going to go ahead and say, okay, that is mu1, y1, mu2, y2. Okay? Everybody see that? So all I did was I just took, y particular, and I plugged it in. And now I'm just going to go ahead and just get rid of all this excess color because it's a little too much. I just wanted you to see what I was doing. Okay, there we go. All right, and now what we're going to do is we're going to rearrange things. Okay, so first thing is looking at this, we're going to look for mu1, things with mu1. So this one, let's see, what else has a mu1? This one. But remember, when you do this, you have to distribute. Okay, so you have to distribute, and here's a mu1 as well. And don't forget, you have to distribute right here. So everybody with a mu1, I'm going to factor him out. And that's going to be y1 double prime plus p of t y1 prime plus q of t y1. Okay, so this is everybody with a mu1, and here it is right here. Notice you distribute the p and the q. Okay, let's now do another one. So let's look at mu2. Okay, so mu2, you have this. Looks like you have this one right here, but don't forget you actually are distributing there. And here's the mu2 over here. So this q, you're going to distribute here. Okay, so here's the mu2. And I'm going to copy it down. So the first one is y2 double prime plus p of t, y2 prime, that's the second one. And then you have the q of t, y2. And everybody had a mu2, so I just put the mu2 in front. Okay, so we took care of those. And then let's go ahead and look at, let's see. So I'm going to look at the double primes. Okay, so I'm going to look at the double primes. So let's look at this one, double prime. And well, I want to have mu1 with derivatives. So, okay, so you know what? I'm going to go ahead and just put these two right here. Okay, so right there, and copy those two. So that's going to be mu1 prime, y1 prime, mu1 double prime, y1. That's this. Okay. And then let's take a look at mu2. So how about this one right here? Okay. So I'm going to take him and just write him down. You can write him down or copy him, put it right here. Okay, so then what's left over is P of t. So I'm going to copy down the P of t. So let's see. So what we have is we have this and this, but remember you have P of T distributed to both of those, right? So I'm just going to write that down. P of T, and then you have mu1 prime y1, mu2 prime y2. Okay. And then the last thing that it did not copy down is this. So I'm just going to say that this and this. Okay, so that's the purple thing. So I'm going to take the purple, or maybe I'll put the purple. Yeah, I'll make the purple right here. Okay, so that's going to be mu1 y1. There's a prime here and prime here, and mu2 prime y2 prime. Okay, so all I did was I rearranged the previous. Okay, I rearranged the previous. And now let me go ahead, try to create some space so that we can just, there we go, write this down. Okay, so remember that y1 and y2 are independent solutions of this. What does that mean? That means that you can rewrite this as L, L of t, y, right, equal f of t. So then you're doing the associated homogeneous, right? So in other words, do you see that if you plug in y1, 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 you should get 0, right? Because that's what a solution is. And if you plug in y2, that means plug in y2, 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 you should get 0 because that's what a solution is, right? So can everybody see that this is equal to 0? Same here. This part is equal to 0 because L of t y1 equals 0, L of t y2 equals 0. Okay. And then let's look at the green. What that green is it's the derivative. And what is the derivative of? And now what I'm going to do is I'm going to now write it this way. I'm going to write it y1 way first, and then I'm going to write it y1 prime. And look at this. Can you see that this is the first guy? Oops, let me write it with green. First guy times the derivative of the second. So that's this. Plus the second guy times the derivative of the first guy. So that first green is the derivative of this. And then the second green is y2 mu2 prime. And look, first guy times the derivative of the second guy plus the second guy times the derivative of the first guy. So you can see that this, when you take the derivative of everything, you're going to get the green, the 2 green upstairs. Okay. And what I'm going to do is now I'm going to go ahead and I'm just going to rewrite this blue part. So rewrite this blue. But I'm going to write it this way and just write the y1 first. Just interchange it, write it this way. Okay. And I'm going to go ahead. Now I'm going to write that purple. And so what I'll do is the purple, let's just see, maybe I'll write the purple down here. The purple, and I'm going to just recopy it, but it's just putting the y's first. So it didn't change anything. All I did was recopy it, but I wrote the y's first. So I just rewrite it like this, okay? And so there we go. All right. So looking at it this way, remember, this is just writing, taking this whole thing, and what you're doing is you're plugging it in here, right? And what we want is we want it to be a particular solution. So we want the left-hand side to equal the right-hand side after we plug it in. So what we want, all I did was I cleaned it up. We want all of this to equal the right-hand side. We want the left-hand side to equal the right-hand side. Left-hand side to equal the right-hand side, right? In other words, we want, after you plug it all in, we want it to equal this. Okay, so then the idea is this: what mu would make that true? So the idea is if we could just find mu1 and mu2 so that this is equal to 0, then can you see what would happen? Then determine the derivative of this equaling 0, and look over here. P of t of that would be 0. So then that would be 0. And if we could find this to equal f of t, then this guy would be equal to f of t. Then what would happen is that you would get, so I'm going to just recopy this now. So can everybody see? If we can make this guy 0 right here, down here, if this is 0, then what you would have is this would be 0, this would be 0. And then if we can find mu1, mu2 so that this is purple equals f of t, then this would be equal to f of t. And then what you really would have gotten, you would have gotten this to be 0, you've gotten this to be 0, and you've gotten this to be f of t, and then left-hand side would equal right-hand side. Okay, so that's the idea. Then the above equation would equal f of t, and then this thing would really be a particular solution of L of t y equal f of t. And remember what that was? That was y double prime plus p of t y prime plus q of t y equal f of t. Remember, it's actually in normal form. That's a 1, right? So what we want is we actually want this thing over here. So just recopy it. It's recopied down here. So we want to solve the system. To get, when you solve that system, you'll get the mu1 and mu2. But actually, you'll get the derivative. And once you get the derivative, you take the antiderivative, and then you'll get mu1 is going to be equal to c1 plus the, mu1 prime dt. And then the mu2 will be c2. So I'm just writing a constant in front. Usually we would write the constant last, right? But I'm just going to write in front, okay? And then you will get the mu1, mu2. And once you get the mu1, mu2, then this is your particular solution. Because the particular solution, remember who the particular solution is, you need the mu1 and mu2 to go right here. And the whole idea was this was your homogeneous. You're going to replace it mu1, mu2. If you can figure out what the mu1, mu2 is, then this would be your particular. Okay, so that's the idea. All right. So let's go ahead and solve this. So I'm going to move this off to the side. That's the goal. You're going to do this. You're going to solve this to get the mu1, mu2. And let's take a look at this. And look real carefully. What have I been writing down all this time, right? Remember I told you I wanted you to practice? I wanted you to practice when it was easy. I want you to go like this, right? So does everybody see? This is y1, y2, y1 prime, y2 prime, right? And then you have mu1 prime, mu2 prime. And then you have 0 f of t. Now, where everybody makes the mistake is that they have the wrong f of t. And the reason why is they didn't put it into normal form. Because if you had something here and you divided through by it to get a 1, that will change your f of t. So you must make sure that this is in normal form. Okay, that is the key thing. That's where everybody makes the mistake. Okay, so does everybody see this is ax equal b? And look at this. This times this, subtract this times this. So what is the determinant of this a? Of course, the determinant of this a happens to be the Wronskian, right? This is the Wronskian of y1, y2. Because how do you do Wronskian? Wronskian is you write the y1, you write the y2, y1 prime, y2 prime. There you go. And then you just go like this and this, right? So you know that it's a fundamental set, right? Because we already know it's a fundamental set of solutions. So we know the Wronskian does not equal 0. So that means if the determinant of A is not 0, then, or if the determinant of A has an inverse, then A has an inverse. So now you know, oh yeah, X is going to be equal to A inverse B. And you know that this exists because, remember what the rule was? Determinant of A inverse exists if and only if A inverse exists. And the only number that does not have an inverse is 0. So what that means is the determinant of A does not equal 0, right? So then A inverse exists. That's another way to write that, right? So then what you do is, so remember who the X is. The X is the mu1 prime, mu2 prime. And what is the A? Well, you know what the A is. It's 1 over, and now look, the determinant of the A is the Wronskian. And then what you do is you flip the main diagonal and then keep the off diagonal the same, but you have a negative negative. Do you remember? And then you multiply with everything else. So let me go ahead. This is like a reminder, a little reminder for everybody, right? There we go. So then we go ahead. This is 0 f of t. And now we can keep, now technically you're supposed to go scale, 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 right? But I always said you can put the Wronskian at the very end. And now let's do row column, row column. But what is that? You're multiplying by 0. So that's gone. And then it's this. So always remember the first is minus y2 f of t. Okay. And then let's do the next one, row column. But look at that, 0. So it's y1 f of t. So notice that the y2 comes first, f of t. And notice that there is also, you know, a negative right here, right? And now do scale, scale. And what you're going to get is, just remember, you're going to get minus y2 f of t divided by the Wronskian, y1. You could just go ahead and memorize this formula, or you can just go through this process every single time. And what are you going to get at the end of the process? You get the mu1 prime, because what are we looking for? We're looking for this and this, which is this, right? And this, that's this. And what are we looking for? We're looking for mu1 prime, mu2, so that this is true. And if all this is true, then this is 0. Remember what that was all about? That would make this 0, that would make this 0, and this would make that f of t, and then left-hand side would equal right-hand side. Okay, so that was the point. Okay, so we're going to integrate. Once you have that, you're going to integrate, right? You integrate, so you have this. So your mu1, so keep your eye here, right? But writing it now out, the mu1 of t is c1. And then remember, you're going to integrate minus y2 f of t over w. You can memorize this formula. I just used the above process. And you can do this. Y1 f of t w dt. Okay. And there you go. And then this is going to be your particular solution is going to be mu1 y1 plus mu2 y2. Remember your homogeneous c1 y1 c2 y2, and then that's your general solution. Okay, let's go ahead and do an example. All right, so what are we doing? This whole process is called variation of parameters, because what the parameter is this. These are the parameters, and we're going to vary them. So we're replacing them by mu1 and mu2. That's why it's called variation parameters, okay? When do you use it? Well, pretty much when you can't do key identity or method of undetermined coefficients. So let's take a look at this. Here is a differential equation. Y double prime plus y equals secant of t. And so you ask yourself, can you use key identity or method of undetermined coefficients? And there are two things, right? First of all, it has to be constant coefficient. So this side has to be constant coefficient. And then the second is that the f of t has to be characteristic form, polynomial, exponential, sine, or cosine. Okay, so this must be characteristic form. So let's take a look at this. When you have this, is the left-hand side, do you have constant coefficients? Yes or no?
Yes.
So this is okay. And then you look at this, and secant, is that polynomial, exponential, sine, or cosine?
No.
No.
So right then and there, then you can't use key identity, and you can't use this, okay? So then you would say, okay, we're going to do method of undetermined coefficients. Okay, so we're going to first solve the associated homogeneous equation. So this is going to be Ly equals 0. Can somebody tell me who is the P of Z so that the L equal P of D?
That's going to be c squared plus 1
Yes.
equals 0.
Okay, so remember the polynomial is this, and then you set it to 0 to get the roots. Okay, and remember, you will have a tremendous temptation to see that and say, oh, there's a Z here. But remember, that's not true, right? Because the Z only goes with the derivative. So there's no derivative, no Z, right? So here there's no derivatives. That's why it's just this, okay? So you set it equal to 0, and you know that you can factor it. Can somebody tell me, how do you factor it?
Z plus I times Z minus I.
That's exactly right. It's very, very straightforward. So then the roots are going to be plus or minus I. And so then the solutions, and whenever you have pure imaginary, then can you tell me what kind of solutions you're going to have?
Sine and cosine.
Yeah, pure sine and cosine. So since that's one I, so this is one t, so we'll just say cosine t, sine t. Write your cosine first, okay? Because that's normal. So YH equals C1 cosine t plus C2 sine t. Okay? So does everybody see that this is your Y1? And this is C2, and this is your Y2. Okay? And now what you're going to do is you're going to do variation of parameters. In other words, you would rewrite it and you're going to say y equal mu1 cosine t plus mu2 sine t. Now remember the mu in reality is mu of t. I'm just being lazy and not writing all of that out because that's a lot of work. Okay, that just saves some handwriting. And you need to memorize two things. The way to remember it is you need to memorize these two. Okay, and notice the way to think about it is when you have the y1 and the y2, y1 prime, y2 prime, that's like writing out the Wronskian. Then you have the mu1 prime, mu2 prime, mu1 prime, mu2 prime, and then you have 0 and f of t. Okay, so that's how you memorize it. So memorize that and just write. You write it out like this. You go y1, y2, y1 prime, y2 prime. Just like you're writing out the Wronskian. Then go mu1 prime, mu2 prime, because you're going the best that you can do is you're going to solve for the derivative of the mu's. And then remember here's 0 and f of t. Okay, so I'm going to write it out one more time because that's how you write it out. Okay, so write out cosine t, sine t. Now take the derivative, negative sine t, cosine t. So you see how that works? Okay, so that's y1, y2, y1 prime, y2 prime. Then go mu1 prime, mu2 prime, mu1. You're solving for this. Okay, and put the pluses in. And then remember you're going to have a 0, and then you're going to have your f of t. Can somebody tell me who the f of t is? What is the f of t?
Secant t.
Exactly. That's who he is, right? Now, that's only true if that's a 1. So make sure everybody, oftentimes if there's like some other number here, they forget to do it and then they get the wrong, they get the wrong forcing. Okay, so write down secant t. Okay, so now you all see how to do this, right? So let's go ahead and let me kind of make this a little bit smaller, and then let's go ahead. So let me go ahead and so you see how these guys, these are the coefficients. So you see, it's not always going to be nice round whole numbers. I wanted you to practice it with nice round whole numbers when it was nice, right? So what you're going to do is you're going to go like this, right? This is your A. Now, this is an easy one because it's only sine and cosine. But you can just imagine they can be very ugly functions right here. And remember, you're solving for mu1 prime, mu2 prime. And then you go 0. And then I'm going to write it as 1 over cosine, just so that might help. Okay? So then what you do is you say ax equal b. You know that this is going to be, the Wronskian is not 0 because you know that from this work over here that this is going to be a fundamental set. So we're just going to say x equal a inverse b. Okay, so x is the mu1, mu2 prime. Don't forget the prime. And then remember what this is, 1 over the Wronskian. Okay, so it's going to be 1 over determinant of this. So this is cosine squared minus a negative sine squared. Does anybody remember what this is?
1.
Yeah. And then you're going to flip the main diagonal, but they were still the same thing. And then you have a sine t here. And then you have a negative sine here. And then remember, you're going to have negative, negative, right? So you have a negative here, and then you have a negative here. So that this part ends up being positive. Okay. So that's this. And then copy down your b. And you want to make sure, of course, that your b, right, the 0, that this is the correct forcing after you put it into normal form. Okay, So this is nice because this is only one, and when you go scale, 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 it's not going to change anything, right? I'll just write it out the first time. I'll just go 1/1, so you don't have to.
Should one of those signs be positive?
Let's see. So I copy it down and then put negative, negative. So do you see this is negative, negative. So this one is going to be positive. Okay. But this one is going to be the original, and then you have the negative in front of it. Okay. So now what you'll do is you can go skip row column. And remember, it's always, this is this, it's going to be 0. So it's always negative this, this, right? So you're going to get negative sine t over cosine t. Okay. And then you're going to have boom, boom. And now take a look at this. This and this is going to be 0. And then what you have is cosine times this. So you have cosine over cosine is 1. Okay. And then, of course, with a 1, you scale just itself. So this is your mu1 prime, your mu2 prime. Okay. And so now you say mu1 prime equal negative sine t over cosine t. So we're going to get the mu1. We're going to integrate negative sine t cosine t dt. Okay, what do we do? Use substitution. And what would be your u?
Cosine t.
And what's your du? Negative sine t dt, right? So then what you end up having is you have du over u. So you know that's ln u, and this is your C1. So you're going to rewrite it. So you write your C1 first, and you go ln absolute value, and now put this in. And now you write it in the original. Okay, so that's your mu1. So mu1 is this. I'm going to go ahead, box it. We'll need it in a moment. Okay. And then let's go ahead and do our mu2. So mu2 prime. Remember, this is the mu1 prime. Okay. Now we're going to do the mu2 prime. Okay. So mu2 prime, it was equal to 1. So mu2 equal integral of 1 dt. So you know that's going to be t plus, and then you just say c2. So let's go ahead and just write it as mu2 equals c2 plus t. Okay, so I'm just doing all this kind of scratch right here. And so what you have is mu2 is this one. Okay. So now we have our mu1. We have our mu2. And remember what the problem is. So this is the homogeneous. This is the particular. This is going to be the particular. Okay, so but look at how the particular always works. Okay, so you're going to have y equal, and you're going to have mu1, y1, mu2. I'll write it for you. Mu2, y2 like this. Okay, but what was the y1? Look, the y1 was cosine, and the y2 was sine, right? So we had this and we had this. Okay, so I'm just going to go ahead and I'm just going to put it in. Okay, so well, I'll just write it in here. Y1, mu2, y2. Okay, so y equal, the mu1 was c1 ln absolute cosine t. That's the mu1 cosine t plus c2 ln sine t times, I don't know, well, c2t, I'm sorry, this was a t, times sine t. So there we go. Everybody see? So just to make it clear again. So this is the blue. And then this is this blue right here. Okay. And now, can you see if you go ahead and distribute, you'll see that you always get the homogeneous solution. This will always be the YH. And then you can just say, hey, well, if the C1, C2 were 0, what you're going to get is ln cosine t. Now make sure you put parentheses around the whole thing. Otherwise, you'll think that the cosine t is inside the argument of the ln. And then this is going to be t sine t. And this is a particular. It's a particular when the C1, C2 is equal to 0. So in this way, you can see you'll always get the homogeneous from this portion again. This was the homogeneous, right? So let's go over here. Here we go. Here's the homogeneous solution to the associated homogeneous. So there it is right here. So right here, what we have is this. And then you have this part right here. Okay. So that is your solution. Okay. So let's go through that process again. Okay. I'm showing you the process. You can also just memorize the formulas over here if you wanted to. You can memorize this formula, that would work. But don't forget that the Y2 and the Y1 are inverted, and then there's a negative in front of the first one. So let's take a look at this one. Okay. So whenever you're talking, you always ask yourself, can I use key identity or method of undetermined coefficients? Okay. So you say, number one, this is an L of t y equal 1 plus t square e to the t. Okay. So really quick, and actually it's not even in normal form. So, but real quick, just leaving it like this before we put it into normal form. Can you use key identity or method of undetermined coefficients? Let me just get rid of this for now. So remember, key identity or method of undetermined coefficients. Left-hand side has to be constant coefficients. Right-hand side has to be polynomial, exponential, sine or cosine. Right. So it has to be characteristic form. So can you see you have polynomial? Even after you divide through by this, you'll still have polynomial, exponential. So this part is okay. But what about this part? Is that okay? No, it's not constant coefficient. So because of that, you can't do these methods. So contrast it with this. Here we had L, it was constant coefficient, but we had secant, right? We had secant right here. So that didn't work. So the f of t did not work right here. But over here, the f of t did work. But remember, look at these, right? Look at this. So you can see that it's not L, it's L of t, right? Now, when you have variable coefficients, we will give you YH. We'll give you a fundamental set of solutions to the associated homogeneous. So first of all, this is going to be your Y1 and Y2 right here, okay? Now, I want to ask you, do you have to put it into normal form? Given that I gave you a solution, do you have to put it into normal form?
Yes, because you need to know what the forcing is.
Exactly. It's because of the forcing. Okay. So does everybody see the above? That's 1 plus t squared y double prime minus 2t y prime 2y equal 1 plus t squared e to the t. So you have to put it into normal form. Otherwise, you will have the wrong forcing. Like so. and you have this, and now you have y double prime. Let me write this smaller now. This can probably shrink, but everybody can see you'll have y double prime minus 2t over 1 plus t squared, and these are equivalent. And then this is 2 over 1 plus t squared y. And now one of these will cancel with one of these. So without doing it, can you see that if you had not divided through, then you would have missed out one of these? It'd be the wrong forcing. So you have to be super careful. You must put into normal form. This must be a 1 so that this is the correct forcing, not this one. Okay. All right. And again, notice that you have variable, you have t's here, coefficient. So therefore, we give you a fundamental set. We will always give you for the test. Okay. Now, do you need to find the characteristic polynomial P of Z? No, because the characteristic polynomial P of Z only is necessary to get your L. The L would be P of D, but do you see that this is not even constant, right? So you don't even, it doesn't even apply because you don't have anything there. So you're not going to use L equal P of D. Plus, we gave you the fundamental set of solutions anyways, okay? So that here you don't. So make sure you always worry about normal form, but here it's not even constant coefficients. Okay, now we're finally ready. So we're going to do variation parameters, okay? So in other words, what you want is, does everybody see your y? YH is going to be C1, Y1 plus C2, Y2. So when you vary, it's going to look like this, okay? So let me write that out again for you. So upstairs, do you see that this is the C1 T plus C2 T squared minus 1. Okay. Then your YP is going to be, instead of C, I have mu1 T mu2 T squared minus 1. Okay. And then always remember how it goes. So you want to find something like this, where you have the Y1, Y2, then you have Y1 prime. So pretend you're writing out, pretend that you're writing out the Röntgen. And then you have the mu1 prime, mu2 prime, mu1 prime, mu2 prime. And then remember, this forcing, it only works for the one with normal form. Okay, so let's go ahead. So does everybody see? So the Y1 was the T. The Y2 is T squared minus 1. One more time. Y1 is this. Y2 is this, right? So then you're going to do the derivative. So this is a 1 and a 2t. And then you're going to do mu1 prime, mu2 prime, mu1 prime, mu2 prime equals 0 equal f of t. All right. And so now, remember, you have this. So this is the t squared minus 1. This is the 1. This is the 2t. So you take the derivative of the guy above. This is your, do you see how your coefficients, these are not nice round whole numbers anymore? This is mu1 prime. mu 2 prime. And this is 0. Oh, I should have written down the correct f of t. So let's write down the f of t. So what was it again? Oh, it was this thing. Do you see how you had to do normal form? So you have to put the right one right here. And so you're going to go ahead and write it 1 plus t squared e to the t, like so. Okay? Remember, we gave you a fundamental set, so the Wronskian is non-zero. So AX equal B, you know that the A inverse will exist. So then you just say 1 over the Wronskian. Let's go ahead and do the Wronskian. I'm going to do it in red. 2t squared subtract t squared minus 1. Okay. And then what you do is, let's go ahead. I'm going to make this a little bit smaller. There we go. Now we have more room, space. So now what we're going to do is we're going to take this, flip the main diagonal, copy down t squared minus 1 and a 1, but these guys all have a negative. And then you say 0, 1 plus t squared e to the t. All right. So looking at this, right, let me kind of make this nicer. Okay. So let's get the Wronskian down, okay? So the 1 is not part of the Wronskian. The Wronskian is the thing downstairs. So sometimes people write this as a Wronskian. That's not the Wronskian. This is the Wronskian. So 2t squared minus t squared, so that's positive t squared. And then subtract a negative 1, so that's positive 1. Okay, we're going to save him for last. Then we're going to go ahead and remember how it works. You always go row column, but remember this is 0. So we always have that negative y2 times f of t. So right there, did I copy down that correctly? I think I copied it down incorrectly. Did I copy this down incorrectly? Oh, this was a t squared right there. I should not have. This right here was a t squared. I copied it down incorrectly. See, I wasn't looking right here. So it's supposed to go right there and it's supposed to have a negative. There we go. Okay, I was thinking, Okay, so what we have is we have the minus t squared minus 1. And then we have the 1 plus t squared e to the t. So does everybody see you have this times this times this? Okay. Okay. Then second one is row column. This times this, of course. And then it's y2 prime f of t. Okay. So no, that's a y1. That's a y1. That's there we go. Yeah. So that's a t. Anyways, it doesn't matter. You just go ahead and multiply it out e to the t. So I'm just copying the red and the black so that you can see it. Okay. And now notice scale, scale. What happens when you scale? Can you see that this and this cancel? Because that's t squared plus 1 or 1 plus t squared. So what ends up happening is that you have minus t squared minus 1, that's the red, e to the t. And then when you do scaling on the bottom, let me go ahead. Scaling on the bottom, you can see that this and this cancel. So we have this. And what you have is t e to the t. And what were we after? We were after mu1 prime, mu2 prime. That's this. This is the mu1 prime. This is mu2 prime. And remember, it's a prime. Okay. And now what you do is you go ahead and you say, here's the mu1 prime, and it is minus t squared minus 1. Yeah, let me write it out. Let me put the minus in front, e to the t. So we want to go ahead and we're going to take this. Okay. And when you have something like this, this is a great candidate for integration by parts. But what will happen is that you'll do it twice. And so when you do more than once, you can use the chart method. And that was in preliminary study guide. So I'm just going to show you how to do the chart method. So if you're going to do integration by parts, and you're going to do 2 or 3 times, the way you want to do it is you want to choose one of them. And on the left side, choose one so that when you take the derivative, it gets simpler and simpler and simpler. So then what you do is you take the derivative, and you can see that this is going to be minus 2t. You don't want to make a mistake. So if it helps you, distribute the negative and then take the derivative. But look at this, it becomes easier and easier and easier. So each time you're taking the derivative, right? And now look, if you keep taking the derivative, it's going to be 0 forever. You can see that, right? It'll be like this forever. And then on the other side, choose something so that's super easy to take the integral. So with this, when you take the integral, you're going to have this. So line everybody up. You take the integral. It doesn't change. You can see it's so easy when you take the integral. So remember how integration by parts, you have u to v equal u times v minus v du. Okay. Now what you do is you draw diagonal arrows. And when you draw the diagonal arrows, it means you're going to multiply. And look, eventually you're going to be multiplying all zeros. So that's why the integration stops. And so you're only going to use the part where you're not multiplying by 0, right? Because over here, eventually you're going to multiply these all by 0. So then these will all go away. Okay, so you won't need them. So the ones that you need are these right here. And with those, what you do is you now do plus, minus, plus. It actually goes like this forever. And now when you write out the final integration, let me go ahead and clean this up a little bit, make it a little bit smaller and move this off to the side. Okay. Okay, so what you have is this is going to be equal to, you're going to look at this, you're going to say this times this with a plus. So write down the plus, and you're going to say minus t squared, oops, let me write it in black, minus t squared minus 1 e to the t. And then you'll do the next one. So maybe I'll even do a different color. So this one, now you're going to do the next one. So multiply it out, and you're going to get, notice you have a minus. And then you have negative 2t e to the t. And then you're going to have this times this, right? And notice you have a plus. And then you have minus 2 e to the t. And then you actually have everybody else, but they're all zeros. And then you have plus C1. Okay, so write your C1 first. C1 plus, and then you can just look at this. So when I look at this guy, I can just go 1 minus t squared. So I'm just distributing the negative e to the t plus 2t e to the t minus 2 e to the t. So this is the mu1. Okay, so this is the fast, easy way. You can see how easy it is to do integration by parts using a chart when you have a whole bunch of integrations to do, okay? So this is the mu1. Let's see. So I'll just say mu1 is right here, and here's the mu1. Let's do mu2. So mu2 prime. So going over here, mu2 prime is right here. It's t e to the t. Okay? And so mu2 equal integral t e to the t dt. Now this one is also integration by parts. It should be super easy because it's only once, but you can still use the chart method. So just go ahead and put the t, because you can see that if you take the derivative of the t, it's a 1. Take the derivative, 0. Take the derivative, it's going to be 0. Take the derivative, it's going to be 0 forever. Then take the e to the t over here. So when you take the integral, it's still himself. So when you want it so that when you take the integral, it's super, super easy, right? So if you take the integral, it's e to the t, and now you're just going to draw slanted arrows. And each arrow means you multiply, but you can see that you're multiplying by zeros over here. So when you multiply by zeros, these guys will go away because it's multiplying by zeros. And this is going to be plus minus. So actually, you can see this is uv times v, the integral, right, u times v minus integral of v du, okay? So when you have all of this, let me just go ahead. Here it is. Just put it right here. So I'm going to move it up here so that's right. Okay, so then what we have down here is first you're going to multiply this. So that's right here. So that's equal to, okay, now look at that. That's a plus t e to the t. And look at the next one, minus, right, 1 e to the t. So that's 1 e to the t. Okay, and then don't forget your C2. So rewriting it out, that's C2 and plus t e to the t minus e to the t. And most of you have had that memorized for this particular one. So this is the mu2. Okay, so then go back. Remember what this is. This is your final answer, right? So this is your final answer. So let's write it down. So y equals, so mu1 was this. This is the mu1 right here. Times y1. What was the y1 again? The y1 was right here. This is the y1. It was a t. Plus, so this is the mu1, y1, plus mu2, y2. Okay. Oh, I'm sorry, mu2, y2. So the mu2 is, let's see, the mu2 is this guy right here. And who's the y2? We can see y2 is right here, right? T squared minus 1. So I'm going to copy it down. T squared minus 1. Let's see. So it sounds like, looks like everything here needs to be shrunk a little bit so I can have a little bit more space. There we go. Okay. So that was the t squared minus 1. Is that right? Yeah. So this is the y1 and this is the y2. Okay. This is the y1 and this is the y2. Okay. And remember, you have to put in parentheses. Okay. Let's clean it up. So after cleaning it all up, right, notice that when you distribute here and here, that part is the solution of the associated homogeneous, right? So this is going to be YH. And then if the C1, C2 were 0, then everybody else is going to be, you know, the particular. So I'm going to write it out. 1 minus t squared e to the t plus 2t e to the t minus 2 e to the t. This whole thing times t. And unfortunately, I wish I could write it all on one line. Let me see if I can fit it all on one line. Okay. So we just did this. Yeah, let me get it right here. Okay, so there we go. And then so we just went this and this, and then the t with all of this. And now what we need to do is this whole thing with this part. So that would be plus t e to the t minus e to the t squared minus 1. Okay, so I'm going to just kind of color code this so that you guys can see exactly what's going on. Okay. So first of all, this and this, right? This and this, right? That's this part right here. That's the homogeneous. And then what you have is all of this, right? And you're going to take this and multiply this. This is a particular solution when the y1, y2 are 0, c1, c2 are 0. So I go yp. And I'll kind of, point out to you again that actually, this came from the homogeneous, and this is the mu1, and this is the mu2. Okay. All right. So this is how you do it. And just remember, pretty much for this course, at least on a test, all you need to worry about is if it's not doable by method of undetermined coefficients or key identity, then you can use this method of variation of parameters. Okay, so now you can do the general green function for second order equations in normal form. It is basically variation of parameters, but written out with a formula. I would say that probably your best bet is to always do variation parameters because you get a lot more partial credit. It's really easy to make a mistake with green functions when mainly because it's just there's just so much like careful notation. But if you are really good with it, I don't mind if you use generalized green function. Okay. So this is going to be derived from variation parameters. It's basically writing down variation parameters, but using a formula. So I'm going to stop right here because it's time, and you can watch the video. But with respect to a test, right? So this is using a variation, generalized green function. So this is a really good example. So I want you to finish this, all right? And I'm going to put up the video really quickly in a moment. All right, guys, so these are our big two methods. So please go through, all your study guides, so 6C and 6D, right? And they're a little bit long, but you'll find that after you do them, it'll go pretty fast, okay? And not everybody gets a study guide, so it's good that you have them.